Okay, right back where we left off, we're going to start actually drawing the geometry to create the indicator clamp. Tate's going to go to a top view by right-clicking and selecting top, and he's going to start with a horizontal construction line from the drop-down menu. He selects horizontal, and he's going to type 2 inches to put it in the center of our 4-inch stock. He's going to create that line, and we're going to see that line come active at our 2-inch up from our Part Program 0, which is in the lower right-hand corner. He's then going to go ahead and create a vertical construction line, once again from the drop-down lines menu, selecting vertical, and he's going to place this line by typing -0.1 in the dialog box and hit create. Now he's going to go to an offset command. Offset command is a very powerful command, and we no longer have to worry about placing positives or negatives into our amount line. The first thing that we're going to do is we're going to offset to the center of the hole, the dimension at the top of your view, showing the 3.671 thousandths. So Tate's going to type in the 3 inches 671 thousandths. He's going to click on the line representing the right end of our part, and he's going to move his mouse to the left and click again. He has now offset that line the desired value. The next step he's going to do is offset that same line in the same direction 1 inch 171 thousandths. What Tate doesn't realize is that any time that the offset value is already blue, he does not have to hit backspace, or he does not have to delete the information that's in that screen. He can simply input the information. As he clicks on the line and moves to the left, he then gets the line located at the center of the radius cutout of 938. Our next step, while we're going ahead and offsetting vertical lines, is we're going to offset the 1/2 inch to the 30-degree angle cut that's on both ends of the forked end of our drawing. So he's going to type in 0.5, click on the line representing the end of the part, and offset that line 1/2 inch. We're now going to start drawing some offsetting our horizontal lines. No chain has to be made to our offset menu. We just simply select the line that we want to offset. First offset we're going to make is going to be 938 thousandths, representing the cutout of the clamping part of our spindle clamp. 938 thousandths, and he's going to click that horizontal line and offset it up, and then click it again and offset it down. Tate is then going to offset for the outside dimension of our part. Our part is 3 inches wide, and we're going to offset it 1.5 inches in both directions to represent the outside periphery of our part. Tate's going to click. There's the top 1.5 inches, there's the bottom 1.5 inches. Tate is now going to offset the line that represents the beginning of our 30-degree chamfer on the right side of the part. The 274 thousandths represents the amount of flat on the end of our part. So Tate's going to type 274 thousandths into the offset dialog box, and he's going to click the offset line that we offset at 938 thousandths, and he's going to go toward the outside of the part. Click, move out, and he's going to do the same up top. Click and move out. Tate's now going to go out of the line drawing menu, and he's going to go into the circle pull down, and he's going to select circle from center radius, the very top one. He's going to set a radius of 938 thousandths, and he's going to turn on snap to intersection, and he's going to snap to the intersection right there. That intersection represents the center point of that 938 thousandths radius. He's now going to change his radius value to 1/2 inch. Move over to the left side of the part, and he's going to snap to the intersection on the middle line, and that's going to represent the 1/2 inch radius on the far left end of the part. Now Tate's going to go back to the line drawing menu, do a pull down, and select line from point angle. Tate's going to type in a 30-degree angle representing half of the 60 degrees shown on the part print. He's going to make sure snap to tangent is the only snap object turned on. And he's going to come down and he's going to click on the small radius on the left hand side, and as soon as he sees it grab hold of the tangency point and both of the geometry structures turn green, he knows he's snapping to the tangent and he clicks. He's then going to type in a minus 30 degrees, which is going to represent the bottom, and he's going to do the same thing, snapping to the tangency. Time to clean up our geometry, so Tate's going to go get our clip tool, also in the geometry drawing tool, and he's going to clean up all the way around the outside of the part, clipping each piece of geometry that's outside the boundaries of our part. Quickly. Cleaning up our geometry allows us to see a little better what we have to work with and how close we're getting to our final project. Alright, so we've got most of it trimmed up. We'll do a little bit more cleanup here in just a little bit. Tate's going to go up once again to our line drawing pull down menu, and he's going to select a line from 2 points, the very top one. He's going to make sure that snap to intersection is the only snap object turned on, and he's going to snap to 2 points signifying the angles on the right end of the part. Snapping from there up to the other intersection. That gives us our 1/2 inch and our 274 thousandths, and he's going to also do that on the bottom of the part. Tate's going to go back into the clip tool, and he's going to clean up those outside corners and all other construction geometry on the inside of the part. One more piece of geometry to draw after he finishes cleaning that up is he's going to go back to the circle drawing menu, and he's going to go ahead and select a circle from center radius. He's going to make sure snap to circle center is turned on, which is going to give us a tick mark on the left end of the part. He's going to set his radius at half the 375.1875. And he's going to select the center of the 1/2 inch radius. He's going to place that circle there, and Tate has completed drawing all of the geometry required to machine the boss of the indicator clamp. He now has to insert a fillet radius. We almost forgot. He's going to select corner fillet. He's going to set his value to 3/4 of an inch or 0.75. And just by moving into the corners where those exist, it's going to automatically trim and place a fillet at those corners, top and bottom. Very good, Tate. Tate is now going to go up to the closed curve. He's going to drop down and pick closed curve, and he is going to create a closed curve out of his geometry. He's going to name this profile and click the create button. The geometry has been created, the stock has been created to the proper size, our user coordinate system and setup has been placed cautiously on the lower right hand corner top of our stock. We've already created one feature to do our facing operation. To get Tate thinking in 3D, Tate's going to right click isometric view. He is then going to get his selection tool, and with his selection tool he's going to select the curve that he just created called profile. He's going to go up to the new feature wizard and he's going to select boss from curve. He's going to say next. The profile curve, because it was pre-selected, is automatically placed in the dialog box and he simply clicks next. He is not going to do an offset from Z-curve location because once again he has drawn his geometry at Z0 where he needs it. So he's going to click next and he's going to adjust the height of his feature to match the print of 3/4 of an inch. He's going to click preview and see the adjustment on the screen and then click next. Tate is going to look through his strategies with climb mill selected and cutter comp, part line programming and depth first. We enjoy these parameters and think that they will probably be fine. He's going to want a rough pass, so he leaves rough pass checked, and he's okay with bidirectional roughing. He also wants a finish pass to achieve his size and desired finish. The step over type of spiral is acceptable and Tate clicks the next button. We are now going to review our default tools, speeds and feeds. The 1-inch roughing tool is acceptable for the tool required and he clicks next. Reviewing the spindle RPMs, he is elected to just click next and accept those feeds and speeds along with the finish tool. He hits next again, reviews the speeds and feeds, has one more opportunity after clicking next to review his operations, and finishes his summary. He accepts his properties dialog box by clicking OK, and he goes up and runs a 3D simulation. There's a little tweaking we'd like to do to this program. Let's go stop our simulation. Let's go to the boss 1 over in the left part view, click the arrow, click the drop down arrow and select properties. Under the rough operation, Millings tab, we're going to adjust an attribute for a rough pass Z increment. Clicking on rough pass Z increment, he's going to set the new value at 125 thousandths. He's going to click set, apply, and OK. Rerun his 3D simulation and see the difference as now we are removing the material 125 thousandths at a time. The next feature we'd like to add to this part, Tate stops his simulation, goes to New Feature Wizard, and he's going to select a hole from Dimensions. Click Next, and Tate notices that his diameter is set at 1/4 of an inch and his depth is set at 1 inch. He's going to back out of this new feature by hitting the Cancel button and show you what happens when he pre-selects the circle representing the hole that he's wanting to create and goes back into New Feature Wizard. It automatically knows that he's going to do a hole, and when he clicks next, the diameter is filled in for him. He's going to adjust the depth by clicking on the word depth and then selecting the top of the feature and the bottom of the feature. This is going to give him a 750 thousandths depth, and he's going to check the box by through because he would like to add the tip of his tool. He then can click next. The location is set by the position of the circle that he drew on the screen. So acceptable, he clicks next. We're going to look at our strategies. We are going to combine with similar holes into can cycles. We are going to spot drill and drill the hole. Click next, and it's time to review our operations. Once again, clicking next reviews the center drill. The speeds and feeds for the center drill will be the next page. Hits next, you see the drill bit. Hits next, and you see the speeds and feeds for the drill bit. Clicking next and then finish, and he accepts his properties with an OK and selects the play button. And there is the first operation of the indicator clamp. Stay tuned for more videos from Rick and Tate.